Okay, so this is the screencast that accompanies the following Ealing film loop, retrograde motion, the heliocentric model. This is the direct sequel to the earlier film loop showing the geocentric model. Once again, I show this film loop in class during lecture. This screencast, however, just accompanies this film loop as an extra resource for you here on YouTube. I also have a raw recording of just the film loop itself posted in a playlist for you here on YouTube. Okay, let me go ahead and set this into motion. Like so. Okay, like in the first film loop on the geocentric model, here with the heliocentric model, the two ex-presidents of the United States are going to once again help us out, John F. Kennedy and Dwight Eisenhower. Okay, now like in the first film loop, they built a machine here. Keep in mind, however, that at the center of this machine is the sun, and then on the smaller arm, closer to the sun than the other arm, is the planet Earth moving faster in its orbit. And then we also have the planet Mars further from the sun, therefore it moves more slowly in its orbit. Okay, they're going to position a camera once again at the position of the Earth. They'll do that for us in just a few moments. Every time that we lap Mars during a positioning called opposition, that's when we see retrograde motion occur over the course of a couple of weeks. They'll show us that here. Okay, so like in the first film loop, John F. Kennedy's job is going to be to screw in the camera, and Dwight Eisenhower's job is going to be to unscrew the light bulb. Notice, however, where they're going with their machine. They're going not to the center where the sun is, but to the positioning of the Earth on the smaller arm. John F. Kennedy waits patiently while Dwight Eisenhower unscrews the light bulb. Something goes wrong here, however. Watch this. Something gets stuck. So JFK has to unstuck it, whatever it is. And then he goes ahead and he screws in the camera like so. Dwight Eisenhower waits patiently. Something goes wrong here again. Notice he's forgetting to do something. What do you always want to do with the camera? That's right, you always want to focus it. So he finally remembers to focus the camera, and now we're just about ready to go. However, the entire time that they operate their machine, it's always going to have the camera pointed in the same direction. So to help us see that, they are very thoughtfully placing this arrow here on top of the camera to show us the direction the camera is always pointing as their machine rotates. Okay, so let's go ahead and light up the arrow like so, and now we're ready to go. All right, so they set the machine into motion, and now watch this. Do you see the retrograde motion occur there between the white lines? Like so. Well, now as seen from the Earth, we then see the following. Okay, now as I mentioned earlier in the earlier film loop, well, the planet Mars does not get larger to the naked eye when this happens. It gets brighter, but it doesn't get larger to the naked eye. It does get larger through a telescope, but to the naked eye, it's once again just a point of light in the sky. Okay, we see the retrograde motion of Mars occur approximately every 2.1 years when we have a specific positioning referred to as opposition. The Sun, the Earth, and the planet Mars arranged into a line like so. And then during opposition, that's then when we see retrograde motion. It occurs over the course of a couple of weeks. So here's what it looks like, first of all, from space, like so. Okay, and then as seen from the Earth, as seen from the camera. So first of all, there's the sun, and then here's Mars undergoing its retrograde loop. Here's the sun again, like so. And then they'll show us one more time. Here's Mars undergoing its retrograde loop, like so.